December 25th, 2016. Guys, I hope everyone's having a Merry Christmas. I hope you have a happy holidays. Be safe, travel safe, and remember what a great country we have when you look around this world. But guys, you're looking at the heliosphere. What that is a protective shield that the solar winds from the sun creates. Now, if you think about the sun, solar winds go out in all directions. And that's kind of what's showing in the blue ball in the center of the image. The dot in the center is the sun. Around the sun in the very center in the blue ball, you can see the lines. That's the orbit of our planets. And then you've got the Voyager 1 and Voyager 2 that have they think have approached the Boschaka point, the outer edges of the heliopause. But what we're dealing with here now is the heliosphere in general. That's represented in the gray area. So as the sun is traveling forward through space, it's traveling at 12 miles per second, and that's 45,000 miles an hour, guys. It creates a teardrop effect, the same way the Earth's magnetosphere does. As it travels around the sun, it's got that blowback. Well, for years, they thought that the blowback effect basically was at one point, one stream of energy blowing back. But now I'm going to show you some of the new data, and there's actually two what we're going to call blowtorches to keep it simple. Now, I'm going to change images, but I just want to give you an idea of what we're dealing with here. Again, the sun is traveling forward 45,000 miles an hour. I talked about the gas cloud in a few videos back, and it's an interstellar gas cloud. It's composed of many things: helium, hydrogen. Hydrogen is much more abundant, but because of what's happening here with the heliosphere and the Boschaka effect, we're starting to get more helium penetration, and that's because of solar minimum. It's weakening the heliopause. That's allowing more helium to blow into the inner solar system, guys, all the way inside the orbit of Earth. Think about that. That's 1 AU, within 1 AU. And they think this total heliosphere is 100 AU. Think about that. The distance from the Earth to the Sun is 1 AU, and the size of the heliosphere, 100 AU. 1 AU is 99 million miles, just to kind of round it off. Now, I want to go into what we can term, to maybe keep it simple, the blowtorch effect. Okay, here is the Sun in the yellow dot. In the white area is what's called a helium cone. And during solar minimum, more helium is penetrating into the inner solar system. Again, inside Earth's orbit. That tells us that the Earth is passing through this helium cone, or this blowtorch effect. So, as we rotate around the sun, just as in this circle of this satellite, once a year, we go through this blowtorch, guys. You see what I'm talking about? Once a year, we go through the blowtorch. Now, this is an older diagram, and there's newer ones, and there's actually 2 blowtorches now. And that could be because of the increased helium, but I'm going to show you the diagram of that. So, as the sun is traveling forward to the left, it's creating a blowback effect. And that's the heliosphere. But now, guys, we're not looking at that. We're closer than that now on this image. So we've got different satellites, and I'm going to move around this image. I've got it enlarged to show you what we're talking about. But again, we're getting a blowback effect in the inner solar system, not around the outside cone of the heliopause. And this is increasing because of increased helium penetration, because of solar minimum, and we're getting deeper into the gas cloud. Now, let me back this out. Now, again, it looks complicated, but it's not. We're dealing with SOHO satellite information right here. We've seen it on LASCO, C2 and C3 many times. We watch ACE, we watch the solar wind speed, and this is picking up helium information. And remember, these give us the Earth-facing images of the sun, also, these 2 satellites. But what they did, and again, SOHO is located here, ACE here, and as the satellites traveled through the cone, they picked up these spikes that you see on the charts above. Now also, let's pull this down. We're dealing with the HUVE satellite. And again, this is older information, but it's a good diagram to explain what we're dealing with, because now we are much closer than this point. This is 98, this is 2001. And we saw coming into this, during the solar minimum, an increase in the helium. Again, this satellite is located here. It rotates all the way around the sun. And so it, just like the Earth and the other planets, it tells us when we move through this helium cone. Now, there's less helium, much more hydrogen. But during the solar minimum and during when you see these coronal mass ejections, guys, what you're actually seeing is helium building up on the surface of the sun, because there's not a sunspot there, there's not a coronal hole blowing it and keeping it back. So as the helium builds up, it explodes and we see the coronal mass ejections. So this blowtorch effect is what we're going through. Now, what's important is to realize that when we get into these solstice periods, everything's kind of tilting. And we go through what's called an alignment, or some people call it a grand alignment, or a galactic alignment, when not only are you entering into this gas cloud, but the Earth is behind the sun when you're looking directly at the center of the Milky Way. So you have an increased pressure from this gas cloud, increased pressure from the Earth being behind the sun, looking at the center of the Milky Way. And again, there's always energy coming from that. Now, what they're not telling us is how deeply we are into this gas cloud, but these instruments will help this out a lot. And I want to give a shout out to the Higher Truth channel. He's paying attention to the helium now. He's trying to straighten out a few people that are not talking about it, but I just want to say this. When we talk about a plasma cloud or gas cloud like that, sometimes we assume that, and we shouldn't, that people are aware of the components as far as helium, things like that. Let's go to one other image. Now you're looking at another star. This is not our sun, but it's giving you a visual indication in infrared of what we're talking about. Around the star, you're getting these two blowbacks, and it's very close. This is the actual star's helium. Pause here, guys, the entire orange area, but the light areas are two helium. These jets, and again, this is infrared from another star, but with new images that came in last year, they're showing now that our sun has double jets like this too. And instead of going back into a single tail, we're getting the double helium trail. Now, they're talking about neutral helium here. But again, remember that once we enter the gas cloud, this bow shock effect that you're seeing allows helium to penetrate, and to be not only to penetrate, but focus directly at the sun and anything that's right behind it in this, what they call a HelioTail, or in this case, double HelioTails. Now, just a little information about helium. And you've got the helium we know about here on Earth, but let's look at the extraterrestrial helium. It says it's found in a plasma state. That's why I call it a plasma cloud. But it is helium, with properties quite different from those of atomic helium. In a plasma, the helium's electrons are not bound to its nucleus. This is important, resulting in very high electrical conductivity, even when the gas is only partially ionized. The charged particles are highly influenced by magnetic and electrical fields. For example, in the solar wind, together with ionized hydrogen, the particles interact with the Earth's magnetosphere, giving rise to the Birkeland currents and the aurora. That's why we've talked about seeing changes in the aurora as this helium increases. Now, this electrical conductivity, another thing with lightning storms, sprites, things like that, things that we don't even know about are about to start happening on this planet. But this wave of energy is not just an impact as far as a compression event, but it can change many other aspects on this planet. But guys, we'll update it as we get more information. We're watching all the satellites. ACE now is very high, to over 600 kilometers per second. The coronal hole is turning away from the planet now, so that should slow down. And now we're coming into that point of that helium tail or HelioTail that we're talked about. Remember, these helium atoms are penetrating deep into the inner solar system, guys, inside Earth's orbit. So that means we're going through this. Now, as we get deeper into the gas cloud, one, it's going to increase. Also, we don't know the length of time we will be in that HelioTail. And it's going to change things again. The aurora. And notice at the very bottom sentence, it affects the Earth's magnetosphere, giving rise to Birkeland currents and the aurora. The Birkeland currents, I've talked about this, the Hederman currents, the Hall currents. Guys, that feeds into the core of the Earth. That heats up things like magma. And as magma moves, you've got problems with earthquakes, displacement, volcanoes, ash, a lot of things. We need to watch it, need to pay very close attention to it. As we saw the pressure building this morning, we've already had a 7.6 earthquake down in Chile, just on shore. It looks like it's almost offshore, but it was so close to right inside that bay, guys, that it actually moved 4 buoys along the Chilean coast. But it was a very small movement because it was on shore. So we're already seeing these strong quakes build. Let's keep an eye on it in the next few days. I'll keep you updated as I get the information, guys. It's a heads up. Be safe.